Okay, good evening, everyone. Let us begin. So, there is a query over here. Will the final exam have only MCQs or will there be programming assignments too? I'm not very sure, Leela, but as far as I know, it will be mostly MCQ based questions. And even if there are certain programming questions, so there will be like MCQ based as well as you get in your quiz. So, not sure if you'll be getting any programming assignments, but yeah, definitely there will be MCQ questions. Okay, so let us begin. Are there any queries from the previous session? By the way, apologies for that initial 24 minutes of no audio, but I hope you didn't miss anything in that because we were just revising the initial concepts of lists and dictionaries. So, tuple onwards, I think there was audio in the video uh, in the previous session. So, if there are any queries, please feel free to ask. I'll be happy to answer any queries you may have relating to the topics that we have covered so far. And somebody had asked me some queries regarding a few concepts that we did not discuss, like magic square and all. So, I'll keep the last session like there will be a 13th session probably that NPTEL will arrange. So we'll discuss all those concepts, including some of the programming questions during that session. So I'll try to cover as many concepts or topics as I can during this 12 week, uh, till the end of the 12th session, and we'll have a revision in the 13th session. Okay, so please let me know whatever queries you may have. Like, if possible, we'll cover it during these sessions, or else we'll keep it reserved for the last session. So today's is the ninth session in this course, and let's get started. So we have covered quite a lot of topics till now. So in the last class, we discussed lists, dictionaries, and tuples. We did a quick overview of what kind of different operations that you can perform on these data types, and we also saw certain differences between these data types. Then we moved on to NLTK library and saw its usage. We'll be using it in today's session as well. Then we went on to seeing Pillow library and saw some application of pandas library to create data frames. I think I missed out on one query that was asked by someone in the last class regarding some default parameter in one of the pandas library functions. So yeah, please let me know what that exactly that query was. We'll see towards the end of this session. And yeah, that was all about the previous session. In today's session, we will try to cover uh, analytical library again in by taking an example or like an application of stylometry. We'll discuss what stylometry is. We'll then move on to NetworkX library, and before that, I'll discuss few concepts that might be needed to understand what we'll be discussing in NetworkX. So I'll keep it reserved for the later part of the session. And then we'll discuss strings in Python, like different kind of operations that you can perform on strings. And this will be useful for you to deal with different programming, questions that you might get in the remainder of this course. So yeah, let's get started. So the very first question is on stylometry analysis. For those of you who know can answer this question, we'll discuss what stylometry is in detail, and then we'll see how we can do stylometry, in uh, Python using analytical library. So we'll see that. But before that, let me introduce what stylometry is. For those of you who know, can answer this question. So okay, for those of you who are joining for the first time or might have missed any of the sessions, can view all the sessions on the YouTube channel. So I have put a link on in the chat. So if you have missed any of the previous sessions, please visit the link and you can view them over there. And if you have any queries, please feel free to ask during one of the live sessions. So this is the ninth session in this series, and we'll be having I think three more sessions plus one extra revision session. Okay. So anyone who wants to answer, who knows about what stylometry analysis is? Sorry. Okay. So somebody answered. Okay. So let us discuss this. In view of time, I'll quickly go over the solution. Okay. So the question is, which of the following is not true about stylometry analysis? So you'll have to be very careful about, the question while reading the question. So yes, what is stylometry analysis, by the way? So let's say there are multiple authors, and you want to find out like if you have been given a text and you want to find out like who the author of this particular text is. So in that case, you try to do some analysis, try to extract certain information from the text, and then compare it with the information extracted from different text corresponding to different authors, and then and then try to figure out who the exact author was. It may not be like it's always stochastic or probabilistic that you may not say it with 100% guarantee that a particular text would have been written by a so and so author, but it gives you an idea that with certain probability that you can say that this might be written by, let's say Shakespeare, or some, if it is a research article, might be by some scientist like Albert Einstein or so. So it all depends on the kind of writing style each author has. And yes, so it is a quantitative study of literature style. That is true. Uh, the way the literature is written, like the kind of vocabulary they use in the text, and so on. And then it is based on the observation that authors tend to write in relatively consistent and recognizable ways. So, for example, if you are a scientist or you are a researcher working in a certain domain, then you might be like using certain terminologies more frequently than any other, you know, regular terminologies. So that might give you, some distinct characteristics in your writing. So that is these are some observations that you can get from the literature that can help you, identify who the author is. And then, yes, of course, it is a tool to study variety of questions involving style of writing. For example, like this is like trending topic now, like people are using these large language models like ChatGPT to, generate text, and it has become a question of ethics that whether a particular text is actually written by a person or student, or is it just, written with the help of any large language models. So in that case, there are certain, tools that are being developed to identify if a particular text is written by a large language model or by a person or a human. So there are certain patterns that these particular tools, which are used to detect, plagiarism in the text, they try to find out certain patterns in the text and see if it is consistent with the kind of writing style these large language models like Gemini or ChatGPT or, whatever language models you have. So yeah, there are certain tools available, and then they are being developed. Although it is pretty tricky in certain cases to decode if a particular text is written by these large language models, because even the large language models are pretty creative. But yeah, so this is the complete field in natural language processing, which try to find out or study the styles in literature, different styles in literature, and identify uh, the authorship of a particular text. And there is also a subfield called some linguistic forensic or forensic linguistics. I don't remember exactly, but yeah, that also comes under the realm of uh, NLP. So yeah, so this is the option C is the correct option in this case. The basic assumption over here is that two people might use different kind of vocabulary, and there might be certain vocabulary that is very unique to a certain person. So yeah, that is the very basis of stylometry analysis. And let us see in Python like how we can you know, extract certain features out of the text. These may not be like the sole features that can be used, but this is just for your understanding and information. So, sorry, I'm not sure if everything is covered in the class. So, yeah, we'll discuss some basics here, which will help you out with solving certain basic, problems in quiz. So as we saw in the previous session, NLTK is a library that can be used for various natural language processing tasks. Um, and one of the applications is stylometry that we'll be discussing today. I think in the previous session, I covered it pretty fast, and then there was one concept that might not have been very clear to you, and which was named entity recognition task, which I discussed. It is not the part of the course, I think. Means like it might not have been discussed and it may not be asked in the quiz. But named entity recognition is something that uh, deals with assigning some entities to given tokens. For example, Dr. APJ Abdul Kalam was born in Tamil Nadu and he was a president of India. So Dr. APJ Abdul Kalam is a person. So this particular token, Dr. APJ Abdul Kalam, is assigned to a category called person. Okay, and then India is a country, and so on. So you take this, text, and then try to identify different tokens and assign them certain categories. So that is what uh, is the basis of named entity recognition. So we won't go into the details, but I think that was not very clear when I tried to explain it in the last session. So yeah, uh, you may ignore it totally. It is just for your information. So coming to NLTK, so NLTK library, sorry, has a wide range of submodules that can be used for various tasks. And in today's session, we'll be looking into stopwords, which we discussed in the previous session as well. Then frequency list, which generates frequency distribution of different words. We'll see this as well. And then in the previous session, we discussed this concept of tokenization. So in this case as well, we'll be using word tokenization and sentence tokenization um, for the stylometry analysis. So as I said in the previous session, NLTK has certain libraries, uh, not the libraries or like certain downloadables that you can download, which include this software stop words and then certain functions. So Punkt is a tokenizer that is used for tokenizing sentences. So is there any query? Okay. And then so we'll let us run this. So we have downloaded all these stop words and the functions that are there in this NLTK library. So if you don't download this, you will get an error if you try to use them because they are not by default there, in the library. Means you'll have to download them from the server. So here is an example text. So as we discussed in the very beginning of the previous session, that a string can be initialized with single quote, like sorry, double quotes like size, or you can even have it with single quotes. But however, if you want to span multiple lines, there's a lot of text. In that case, you can use this uh, double quotes used thrice or single quotes used quotation mark used thrice to initialize a string in Python. So this makes it cleaner and easy to read. Okay, so here is a sample text. As I discussed in the previous session, you can also read text from uh, a file, so a text file using file of handling. But in this, we'll just take this sample text, short text over here, and do certain operations on this. So first of all, as I said, to identify if a text belongs to a certain person, you will have to first of all extract certain discriminative features. It is applicable for any task in the realm of machine learning. For example, if you want to classify different images, uh, let's say images of trees and cars and so on. So you will have to extract certain features from the images, and then based on those features, you will be classifying the images using certain machine learning models. Okay, so that is altogether a different ball game. So let us not go into the details of that, but the main thing that we'll be discussing over here is the feature extraction part. So what kind of features we can extract from text that will help us, identify if a given text belongs to a person. So one of the features that can be used is the frequency of the words or the kind of words the author is using. Okay, so for that, the first step that we'll have to do is to tokenize this particular text into words. So we'll have to do the word level tokenization, wherein each word is considered as a token. So this word tokenizer that we have imported from NLTK.tokenize will do the tokenization task. So let us run this first. We'll go step by step and then understand what's happening. So we have this text, we have this word tokenize function, which will tokenize this text into words, and then let us just print the words. Okay, so you can see over here, it has created a list of all the words that are there in this particular uh, text. But it might have repetition. For example, stylometry is appearing multiple times over here in this text. So this list will also have stylometry multiple times. Okay, so sorry. So we have done this. Now, we also saw in the previous session that there might be certain words that are very frequently used in almost all the text. For example, like the words like is, the, of, the, and articles like a and the, and so on. So they may not add more meaning to, the text, or like try helping you discriminate text belonging to a certain author or not. Sorry. So in that case, you will have to remove stop words as well from the given set of words that you are getting from a given text. So what's happening over here? Let us see it in let us run this first and we'll go into the details of what exactly is happening. So there are a lot of concepts that are being covered here. So first is getting the list of stop words. So stopwords.words will give you all the stop words. Let me just comment this out. So stopwords dot words and English will give you the list of all the stopwords that are present in the NLTK library for English language. We also saw it for Spanish and other languages. So there might be some other languages as well for which there are stopwords available in the NLTK library. So for English, we have all these stopwords. And what's happening over here? So when you pass these stopwords to this set function, So let me just run this. So it is taking all the unique stop words that are present in this particular uh, list. Let me show you it to you with an example. So let us say you have a list one, two, three, four, five, and six. So here three is repeating twice. However, if I write like this and print s, there is a comma missing here. Yeah. So once I convert a list to set, you can see that all the repetitive elements over here are getting removed. So there is only one occurrence of this three that is mentioned in this set. So the use of this set over here is to just remove all the, repetitive elements in the list and take only the unique elements. So that's what is happening over here. Stopwords.words English might have some repetitive elements. We don't know that. So that's why we are just simply converting it in to set and then taking that, set of stopwords for iterating over all the possible stopwords. And then what we are doing, uh, we are getting the filtered words. So whatever words are there in this words variable or list, which are not stop words, they will be added to this filtered words. Okay. Now, this is the comprehensive way of writing or creating a list with this complex, uh, formula or statement here. So let us understand it step by step. So word dot lower for word in words. If word dot is al num and word dot lower not in stop words. So you might be wondering what's happening over here. So let us break it down into this. So I have just written a comment over here for you to understand. But before we go on to the understanding this, is everything discussed so far clear? Is there any query so far? Is it clear why the set was used over there on list? Okay, great. Okay, so what's happening over here? So filtered word. So this is equivalent to writing this. So what we are doing over here, we are creating an empty list and then we are iterating over all the words in this particular word list. So for word in words, then we are converting every word to its lowercase form. So a particular word might have, like, for example, stylometry over here is having capital S and here it is having, small s. So we want to treat all these instances of stylometry as one. Like this is stylometry, this is different. But if stylometry is used somewhere else with, for example, over here with small s. So we want to treat all these instances as same. So in that case, what we are doing, lowercase word. Uh, so we are converting the word to lowercase. And if the word is alphanumeric, so this word word dot is ALNUM. We'll discuss this in strings like in the later part of this session. But what this particular function does is to see if a particular word is alphanumeric or not. For example, let me show you to you. Let us say I have this word, Saish, and I want to check if this word is alphanumeric. So this is true because it contains only alphabets. So a string is alphanumeric in nature if it contains only the alphabets and numbers. For example, like let me say Saish 1, 2, 3. So this string is also alphanumeric in nature. However, if I add this at over here, special character. So in this case, you will get this uh, result that this particular string is not alphanumeric in nature. Okay. So there are other functions as well, like to see if a digit is only alphabetical in nature or has only string numbers or has special characters and so on. So we'll see that in the strings part of the session. But yeah, this was about this alphanumeric. So what's happening over here? So we are just interested in the alphanumeric words in this particular text. So if a word is alphanumeric, if this particular word is alphanumeric in nature, and if this lowercase word is not in the stop word, okay? So if it is not a stop word, then just append this lowercase word to the filter words, okay? This filter words may still have multiple instances of given word. So we'll deal with that later. So let us go on to the next part. Okay. So is this particular part clear? Like what's happening over here in the filter words? How we are getting these filter words? Okay, great. Yeah. So please try it out on your own. Like just try running this code and then try to understand it yourself later as well. Like when you play around with this notebook. So what's happening now? Like over here, we are passing this filtered words to this function freq disk that we have imported from NLTK.probability. So this comes under the realm of probability and statistics. So there are these frequency distributions that are there in probability. So here we are trying to, you know, plot a histogram sort of a thing for each unique word that is there in the text or in this filtered words. So as I said, like stylometry might have multiple instances like this stylometry and this stylometry, and we want to treat them as same. So that's why we converted everything to lower. And then we'll try to find out the frequency of each word, unique word, like stylometry and this stylometry is same. So it will be counted as 2 and plus 3 and wherever stylometry is coming into picture. Okay. So this frequency distribution will convert, all this. So let us see the output of this ftist. Okay. So I'll just keep it for you over here. Okay. So yeah, let me run this. So we have removed the stop words, got the filtered words, and passing this filtered word into this freakdist function, and we are printing this ftist. Okay, now let me use this particular function ftist dot most common. So, so now you can see over here. So this most common function gives you the top n most common words that are used in the text. So it can be anything. So if I say 20, so these are like the 20 most common words. So what it is giving over here? So it is giving the frequency of each of these words sorted in the descending order. So stylometry is the word that is occurring, that is the most frequent word in the particular text that we have used, sample text. It is occurring 6 times. Then there is this word called me, which is occurring 4 times, then used occurring 3 times, identification occurring 3 times, and so on. So you can see that there are only a few words that are occurring more number of times, whereas the other words, uh, although they are, uh, uh, given the label of most common, but these are like all occurring only once. So yeah, in most of the text analysis, you will find this kind of like a ZipF distribution. Uh, Let me show you what ZipF is. So you'll see this kind of like a graph if you try to find out the occurrence of, either phones like different vowels or different syllables or words or different kinds of tokens. So you will always find that there are certain, tokens which are very frequent, and there are many tokens which are less frequent. So this also comes under the realm of this power law. But yeah, let us not go into the details. But yeah, more generally, the distribution of the words or tokens that you will get in any text in this world will be generally this will follow this zip up kind of a distribution. Okay, like only a few having more frequency and many of them having less frequency. We'll come to this again, like in the network X part as well. So yeah, please just keep that in mind. This particular law. Okay. So yeah, this was about getting the most common words, and then we got one particular feature from the text. Like these are the most common words this which is present in this text. So you can apply it on any text from any book and see what kind of words a particular author is using the most. Okay, that will give you one feature that might be helpful to discriminate a author from another author. Now, this was one feature. Let us try to get another feature. For another feature, we'll look into sentences. So here we tokenize words. Now we are tokenizing sentences. So from this text, we'll extract all possible sentences that are there. And then we are, in this case, we are just trying to find the length of each sentence. Okay, so this is another feature, like how long sentences a particular author writes. Like I might write very long sentences, and some other person may not write those long sentences. The sentences might be broken into sh many small sentences. Okay, so yeah, so this all depends on the kind of writing style you follow. So this is one of the features that you can extract from the text. So first, you'll have to tokenize the sentences, and then same as what we did over here. Uh, we are trying to shorten this particular B code into one line. So for sentence in sentence, sentences, whatever list of sentences that you get after tokenizing this text, we are trying to find out the list of word tokenized sentence. Okay. So what's happening over here? Let us see step by step. So this will give me a list of all the sentences that are present in the given text. Okay. Now, what's happening over here? So for sentence, so here you are creating, and this is equivalent to this particular code over here. So I've just written it in just to clarify what exactly this code is doing. So sentence length is an empty list first. For every sentence in this sentences, you are getting a list of words in each sentence. Okay, that will give me the length of that particular sentence. So the length of each sentence is equivalent to the number of words here. We are defining it that way. Okay, it can be, just simply len of sentences as well, like len of sentence that can also be used. But here we are just using the number of words as a measure to measure the length of given sentence. And then you're finding the length of this particular list. So this word tokenize of sentence will give me the length of list of all the words that are present in that sentence. And then you're trying to find out the length of this list. Okay, so that is the length of the sentence. And then you are appending it to the sentence length list. Okay, so let us run this. So you can see that there are like 8 sentences in this text, and then each sentence is having certain number of words over here. Okay, you can find out the average of this list as well, like what is the average length of, uh, sentence that a particular author has in their writing literature. So that will give you an idea of like this feature will also give you an idea of the kind of writing style a particular author has. Okay, so average sentence length can be computed as sum of the sentence lengths upon length of sentences. Means the length of this particular or the number of sentences that you have. So it can be simply like computed as a mean of this sentence length. So that is a simple thing, but just to show you what exactly is happening over here, uh, how the average is being computed. I've written it this way. Okay. So is this particular part till now, is everything clear to everyone? Yes, Leela, that shows by default the sorted ones, most common. Okay. So is it clear, everyone? Whatever we have discussed so far? Please feel free to ask, like if you have any queries. So we'll move on to the next part. Okay, so this was about finding, distribution of unique words and then finding the average sentence length, like kind of in terms of the number of words in each sentence. So there is another metric that can be used is like type token ratio. So type token ratio is nothing but like how many unique words are there in this particular text upon the total number of tokens that you have. Yeah, okay. Total number of words that you have. So filtered words contained multiple instances of a word like stylometry was appearing six number of times and so on. So this will give you a total number of tokens that you have. These are like after removing all the stock words. And then len of set of filtered words will give you a unique number of unique a list of or set of unique tokens. So you have unique tokens and you have total number of tokens. So the ratio of these unique tokens to total number of tokens is called type token ratio. This is also one of the, features that can be used to differentiate authors or identify the authorship of a given text. So let me quickly run everything at once. So in this case, you had this most common words that we saw in the frequency distribution, then average length of sentences that we saw over here, like by finding the length of each sentence in terms of words, and then the type token ratio over here is 0.81, which means that there are more unique number of words. So if this is close to 1, it means that there are more unique words used in the given text, and there is very less repetition of each word. Okay, so that was all about, some basic stylometry analysis that you can do using this kind of features. So you'll have to extract these features first and then compare these features across different texts. Okay, and if a particular person is writing a certain text, then they may have like, consistency across a given like or in their style of writing. So this was all about stylometry analysis. So I hope everything is clear so far and we'll go on to NetworkX library. All good? Okay, great. Fine. So now let us discuss NetworkX library. So what NetworkX library deals with is graphs. So many of you might not be from computer science background, so I've just prepared a primer for what graphs are. So let us quickly discuss what these graphs are. So graphs. So there are two types of graphs like that you as you generally get like the pie chart and all. So those are also kind of graphs, but graphs in so there is a subfield in computer science called discrete mathematics or in mathematics in general, which has this graph theory, uh, and all this theory related to graphs come under the realm of this graph theory. So what is a graph? A graph is nothing but a set of nodes and edges. A node is a point in the space. It can be anything. We'll discuss that. And then each pair of node can be connected with an edge. Okay. So this is the basic definition of a graph. a graph consists of nodes and edges, uh, and every pair of node might be connected with an edge. And there are different kinds of graph that you may have. So for example, let us go back to this. So there are multiple types of graphs. These are not the only types of graphs that you can have, but these are like in general, you can find these categories of graph. So first is undirected graph. So undirected graph is nothing but a graph in which the edges are not directed. In me, so for example, this over here. So there is no direction of this edge, right? Like so, there are nodes and then there are edges, but there is no direction. Whereas there is another category of graphs called directed graphs, in which you will have certain edge direction to each of the edges. So there are certain applications in computer science which will want you to use directed graph instead of undirected graph. So we'll discuss that as well. Like if time permits, we'll see some applications. But I'm just covering these basic concepts or terminologies that are there in the graph theory, which might help you, to understand the network X library and also, g- um, the kind of functions that you have in that. So this was about directed and undirected graph. This is very simple. Uh, and directed graph is also called as digraph. Then you have weighted and unweighted graph. So let me go back over here and okay. So in case of weighted graphs, the edges that you have will have certain weights. For example, let's say these nodes are representing certain cities in a country, and each city is connected via road. Okay, so this particular edge just represents the distance between these two cities. The road may not be the straightforward, but this is just like a distance that you have to travel from city A to city B, uh, and sorry, and it shows the distance between these two cities. It can be anything as it need not be cities, but this is just for example. And this direction over here, it shows that there is path only from B to A. So there is no way you can go from A to B directly. You can only go from city B to city A, but not from city A to city B. So this is just an example. Maybe there is some barricading happening over there. So there might be some blockage on the road. So in this case, this directed edges come into picture, and then the weighted concept of weighted graph come into picture. Okay, unweighted graph is nothing but like all the edges don't have any weight, so they are treated equally. Whereas in weighted graph, you will have certain weights associated with each edge. Okay, then coming to connected graphs. So connected graphs are nothing but graphs in which there is a path. A path exists between every pair of node. Sorry, connected graph. So whatever two pairs of node that you take in the graph, there will always be a path. So for example, this node and this node. So they may not be connected directly, but there is a path from this particular node to this node. There is an indirect path. Okay. There is another category of graphs called complete graph, in which you have direct edge between every pair of nodes. Okay. So a complete graph is also a connected graph, but every connected graph may not be a complete graph because there might not be. So this is the connected graph because you can reach any node from any other node. However, there doesn't exist age for every pair of nodes. Okay, so for example, in this case, there is no age between this particular two nodes. So this is not a complete graph, but this is a connected graph. Okay. And then there is another category of graphs called disconnected graph. So for example, you may see think that these are two graphs, but if it is defined as a one single graph, in this what's happening is there are two subgraphs. This is one subgraph and this is another subgraph, and then these two subgraphs are disconnected because there is no way you can go from one node to another node in these another subgraph. Okay, so the only difference between connected and disconnected graph is that the in connected graph you can reach any node from any other node, whereas in disconnected graph there might not be some edge available or okay. So this was all about, undirected, directed, weighted, unweighted, connected, and disconnected graph. And then, as the name suggests, like the next category is cyclic graph and acyclic graph. So let's quickly discuss these as well. Okay. So a cyclic graph is a directed graph or undirected graph in which a cycle exists. For example, like if you start from a given node and then go and come back to the same node, it means that there is a cycle in this particular graph. Okay, whereas acyclic graphs are nothing but the graphs in which there is no cycle. For example, over here. So if you go from A to B, B to D, you cannot go from D to A again. There is no such path back to A. Okay. So this is an example of acyclic graph. And then if you can come back to A with certain path, then that is
So
that.
we can't see the
Oops,
screen.
oops. Sorry. My bad. Yeah. So yeah. So I was just explaining this. So there is this graph in which there is an edge from A to B and B to D, but there is no other path through which you can reach A. So this is an example of acyclic graph. There is no cycle in the graph. So cycle means like if you start from a node, you can reach back to the same node by some path in the graph. By path, I mean following some edges. Okay, so path is also a formal term that is used in graph theory, and we'll see that in the shortest path concept later. And then cyclic graphs are graphs in which you can, reach to any a particular node following a given path again. And so yeah, we discussed already complete graph. So complete graph is nothing but a graph in which every node is connected to every other node directly. Okay. And then we have bipartite graph. Uh, Let me discuss this. So bipartite graph is nothing but a set of two node, uh, and then within each so there will be an edge from one set of nodes to another set of nodes, but there won't be any edge within this particular set. So this can be like, uh, let's say a set of people or students, and this is like a set of books that they read. So there can be age from like, this particular student might be reading these two books, and this particular student might be reading these two books. So this particular kind of graph is known as bipartite graph, in which you have different sets and there are edges between the nodes in these sets, but there is no edge within the particular set. Okay. So this was about the bipartite graph. And then there are two graph types left. This is actually one only. So there are categories of graphs called trees. Okay, so you might be familiar with this, but trees are nothing but some acyclic graphs in which there is a root node, and then there are some child node. So every node might have child subnodes or like a child nodes, and then the node at the top is called the root node, Unlike the conventional tree that you see, like the root is at the bottom and the leaves are at the top. In the case of tree data structure or tree, graph, the root is at the top and the leaves are at the bottom. Okay, it can be oriented anyway in any way. For example, over here. So this is also a tree graph or tree data structure in which root is over here. You can consider anything as root over here. Maybe this, if this is the root, then this is a child, and then it all depends on which node you are treating as a root. For example, this is a root over here, and then these are all the child nodes, and so on. And there are in that there are some special kind of trees called carry trees. For example, over here, every node in this particular tree has two children. Okay, so this is the binary tree. And if it were having three children, so it would have been like a ternary tree and or a four quaternary tree. In general, it is called a k-ary tree. If it has k, if every node has k or less, sorry, k number of children. Okay, so this was all about basic graph theory, and there is one thing that I've not discussed, that is spanning tree. A spanning tree is nothing but like if a in a given graph, for say, let me show it over here. Sorry. So let's say this is a grid graph that you have, and then you want to find out a subgraph in this particular graph. So this is a complete graph. Let's say this red color one, edges that you are seeing. And I want to find a subgraph, like all these nodes are included, and then you have a subset of all these edges. Okay, so these dark blue ones are the edges that you have covered. So you find the minimum number of, or the certain set of these edges such that this graph remains connected. So you can visit any node from any other node, but you are even after removal of certain, uh, uh, edges over here, just to avoid any cycles. So a tree will never contain a cycle. So this is again a tree-like structure that you are creating out of this complete graph or connected graph, and that is called as a spanning tree because it spans every single node in this particular graph. And there is something called as minimum spanning tree, which takes into account the minimum number of edges in the graph. Like you may so remove certain number of edges, and at certain point you may not be able to remove any more edges. Because if you remove that particular edge, there will be a disconnection in the graph. So that kind of a graph, subgraph from a graph is called a minimum spanning tree of that particular graph. Okay. So this was all about the basic graph theory that I wanted to discuss with you before moving on to the NetworkX library. So is it clear? Can a complete graph say be a cyclic graph? Yeah, it can be a cyclic graph as well. Does unweighted graph mean equidistant? Uh, yeah, there is no notion of distance over there, Moksh. So there is no uh, concept of distance involved in that. Can all trees be said as graphs? Yes, all trees are graphs. Okay. So the moment you add, so just to clarify, Moksh, the moment you add distance, that means you are adding weight to the graph, edges. So that becomes weight, that comes under the realm of weighted graphs. So yeah, that's the only difference between weighted and unweighted. You don't have any notion of weight involved or distance involved in that. Okay. So are there any queries so far? Is everything clear? Okay, great. So let us move on to NetworkX library. So NetworkX is a library in Python that you can use to create network or graph, uh, to be simple. Okay. So as we saw, a graph is nothing but a collection of nodes and edges. So to create any graph, so even a single node, let's say. Okay. So let's say this graph would have had only this. Forget about this part. So this can also be a graph in general, like without any edges. So it has only one node and no edges. Okay. But in this case, if this entire thing is considered as a graph, then this is a subgraph. Okay. And then this is a disconnected graph in general. Okay. So what we are doing over here. So we are importing network X as NX and we are creating uh, a graph, an empty graph, which has no nodes and no edges as of now. Okay. So nx.graph will give you a empty graph and then you want to add some nodes to it. So you can use this function called add node. So G is an object which is a graph object created using network X library and you are adding a node to it. Okay. And this node can be anything. It here I'm adding it as number. It can be string as well, like India and so on, or it can be floating point numbers like 2.35 and so on, or it can be either functions in Python. So you can have a node of function in Python. So that is also possible. So it can be a graph of functions. It can be a graph of lists as well. So you can have every node as list. So let's say one, two, three. You can have any data structure here, like tuple or dictionary or even another graph inside the graph. So anything is possible to create a graph of graphs. What I mean by graph of graphs, let me give you a simple example. Okay, or let's say social media network. Okay. Uh, Sorry. Okay. Yeah, just trying to find out some good way to get this. So let's say like you all of you might be using some mode of social media, like some medium in the social media, either Facebook, Instagram, or WhatsApp. So you might be connected with your friends. So each node in this particular graph is every individual, and then every age is just a connection or the relationship between any two people. That relationship is just a basic connection, or like you are in contact with them, or you are friends with them. That's it. So this is a simple social network graph. Okay. However, this can be a complex graph as well. So this is a graph of countries, different countries over here. And each country can have, you know, its own graph within itself. So there can be a connection of people inside this country, and then this country is considered as a single node, and then it is connected to other countries. So this can be like a trade between these countries and so on. Like it all depends on kind of notion that you add to these edges over here. So yeah, a graph can be a graph of graphs, and be wherein each node can be a graph in itself. So, is this particular part clear to everyone? Is it clear or not? Oh, great. Okay, so what we are doing over here, we are adding a node, and then either you can add a node directly or you can add a node from a list. So, adding nodes you can add nodes, you can use this function add node to add a node directly or add nodes from, and you can pass on a collection of objects here. Uh, so, all these nodes will be added 1, 2, 3, 4, 5. Okay. And then add an edge. To add an edge between any two nodes, let's say 1 and 2. So you have to pass g dot add edge and then the source and the uh, target. Okay, this will create undirected graph. There is something called as digraph, directed graph. Like you can use this digraph or something. We'll not go into the details of that, but this is just for your information. You can explore that later at your convenience. So just wanted to discuss some basic graph theory and application of networks. So you can add an edge between any two nodes. Then similar to add nodes from, you can also have add edges from, and you can pass on the list of tuples. So in this list, each tuple represents an edge. Like 1, 2 is like edge between 1 and 2, 2, 3 is edge between 2 and 3, and so on. Okay. These are undirected, so there is no direction from 2 to 3 or 3 to 2, and so on. Okay. So nodes equal to G dot nodes, and edges equal to G dot edges. So this will give you the list of edges and nodes that you have. So let us run this particular bit. Sorry. Okay. So nodes will have 1, 2, 3, 4, 5, and edges will have 1, 2, 1, 5, 2, 3, 3, 4, 4, 5. We'll see how to visualize this as well. So this was all about, getting the like creating a graph, adding nodes to it, adding edges to it, and
Sir,
then
we are
getting the,
having the screen, graph screen.
oops, sorry, my bad again. Yeah, so thank you for pointing that out, Leela. So yeah, what I was discussing is like creating a graph over here using this nx.graph, adding a node to it. If you want to add node from a list, you can use this add nodes from, and then you can add direct edge over here, like a edge directly over here, or you can add edges from using a list of tuples, wherein each tuple represents an edge uh, in the graph. Okay, and then what I was discussing is getting the once you have this graph ready, so you can get the list of all the nodes and all the edges using this G dot nodes and G dot edges, where G is the graph that you have created. Okay, so I just ran this particular thing over here and then showed the output. So now to check if a given graph is having a given node or not, so there is this function called has node or has age. Okay, has node by as its name suggests, it checks if a particular graph has this particular node or not. And then nodes are also called in graph theory vertices or vertex. A node is also called a vertex. So yeah, just for your information. So if you come across this terminology like vertex and edges, so it is same as nodes and edges. So please don't get confused. And then has age is like checking if there is an age between these two particular nodes or not. Okay, and then similarly, uh, similar to other data structures wherein you can remove certain things, elements in this graph data structure, you can also remove nodes and remove edges. So if you want to remove the node 4, you can remove node using remove node function, and there is this remove edge function which will remove a particular edge. Okay. There might be some other functions as well available, so you can explore them later. Then basic graph information, like what is the number of nodes. So G dot nodes and G dot edges will give you the list of all the nodes and all the edges. However, this number of nodes and number of edges will give you only the number of nodes that are present and number of edges, not actual nodes and what are the actual nodes and what are the actual edges in that particular graph. So this will give you a basic graph information, and then you can draw the particular graph. So let us run till this point. Okay. So what I have done over here, so I've just plotted this NX using this network X library. There is this spring layout that is getting generated for this particular graph, and then you're using this nx.draw function. You're passing on this graph object the positions that that is generated with this layout. Then with labels equal to true means that you have to add this, label 1 to 5 and all on the graph nodes. Then node color what you want. So this is sky blue. You can have any predefined color over here, or you can have a hex code and so on. And then node size, you can change the size of the nodes as well. Then what should be the font size over here on the graph? And then font color, it's in black in color, and font weight, if it should be bold or unbold, and so on. And what title you want to give. So this is in the matplotlib library. So plt.title. So this will add a title to this graph, and plt.show will just display this particular graph. So in this graph, what we have done, we have added 1, 2, 3, 4, 5. We added an age between 1 and 2. Then we have added age between 1 and 2, which was already existing. That doesn't make any difference. Then there was an age added between 2 and 3, 3 and 4, 4 and 5, and 5 and 1. Then a particular node 4 was removed, so that's why you are not seeing 4 over here. And then we have also removed age between 1 and 2. So 1 and 2 age was also removed. And then we plotted this particular graph. So it is a disconnected graph with age between 2 and 3 and 1 and 5. Okay. And 4 was removed from the list. So is it clear so far? Any queries so far? Okay. Yeah, please let me know like whenever you find it difficult to understand, I'll explain it again. So this was about drawing the graph, and then you can get the list of, neighbors of a particular node. So what is neighbor? In this case, 2 has neighbor 3 and 1 has neighbor 5, and vice versa. So if it were, there were 4 over here, like 4, so 3 would have had neighbor as 4, like if there was an age between 4, 3 and 4. So all the nodes which are connected to a given node are its neighbors. Okay. So, sorry. So this particular function, okay, where it is. Yeah. So g dot neighbors will give you the list of all. So give you an object which will have a list of all the neighbors of a given node, and you are just converting it to a list over here. Okay, so this is just a neighbors of 2. And then if you want to check if a graph is connected or not, so you can use this isConnected function in NetworkX, which will give you like here the graph is disconnected, so it will be false. It will return false. If it is connected, then this will be true. Then there is this concept of diameter. Actually, I won't go into the details of what diameter is, but diameter is nothing but like a spanning, like a shortest. It is actually called longest shortest path or something like that. Which is out of all the shortest path, whichever is the longest, that is the diameter of the graph, G. So that is a pretty confusing notion. So you just ignore that. It is not going to come in your paper or exam. But yeah, you can learn more about diameter in graphs uh, later. And then, yeah, shortest path, as I discussed. So in any graph, sorry, a shortest path is a path that gives you the least weight. So for example, in this case, let me bring up a weighted graph over here. So in this weighted graph, from node 2 to node 4, there are multiple paths possible, like 1 to 2 to 1. Like let's say these are cities. And from city 1, city number 2 to city number 4, there are multiple roads, and you want to take the shortest route possible. Okay, so this route is nothing but the shortest route is nothing but the shortest path that we are talking about. Okay, so this was in the case of the directed graph, whereas in the case, sorry, in case of weighted graph, whereas in case of unweighted graph, for example, this social media graph that we have seen, so wherein there was no age as such. Concept of age over here, I mean, it's like a weighted age. So it is just the connection between the two people. So here in this case also, you can also have a notion of path. So let's say you know someone and that someone knows some other person. Okay. So you know this other person through this person. So the age or the path between you and the other person, third person, is 2. Okay, so you are traversing two, you have to go through one person in the middle. So, for example, like let's say person A knows person B knows person C, and person C knows person D, and there is no direct connection between A and D. So, to reach D, you'll have to go through person B and C. Like person A needs to go through B and C. So, in that case, you have this notion of path. So, the path is either you can consider it as a number of nodes you have to go through, or the edges you have to go through. Okay, so that depends on the kind of definition you're going giving to the length of the path. But yeah, this is about the path, shortest path. So here, in this case, you're trying to find shortest path in the graph G. The source is 2 and the target is 3. Okay, so you have to pass on the source node and the target node over here. Then generating a random graph, we'll see it later also. So this Ados-Renyi graph is Ados-Renyi is a model actually, like which or an algorithm which actually creates a random graph. So there is a detailed algorithm that you can look into. So it accepts two parameter over here: the number of nodes that you have, and then the age probability. So what is the probability of two nodes being connected? So higher the H probability, more are the chances of that random graph being a complete graph. Okay. So if it is one, so every node is having an edge. Okay, between them. So that was all about this creating a generating a random graph. We'll see different kinds of graph that we can generate using NetworkX library. And then you can, export a given graph to a file, like you can write a text to a file. So you can even export this graph, whatever graph you have generated with the information of nodes and the edges. You can write that to a given file. You can have any extension over here. I've just written it as sample graph dot adj list. This adj list is nothing but adjacency list. So in computer science, the graph data structure can be represented using adjacency list or adjacency matrix. What these things are, I may not be able to cover it in detail, but let me just show it to you over here. So these are the two. So there is this list data structure. In Python, we have seen lists, but in if you learn C and C++, you'll understand it better. So let's say you have this graph 1, 2, 3, 4, 5, and so on, and there are edges between these graphs. Okay, between the nodes. So you have the list of nodes. Sorry, I hope this is visible to everyone. I'm just trying to zoom it in, but yeah, it's getting truncated. So 1, 2, 3, 4, 5 are the edges, and then one is connected to 2. So this is the list. This is the adjacency list representation, wherein each node is connected like a list. So there is this notion of list or list data structure in computer science, in which like you have a pointer to another node, and then uh, you can create a list out of it. So yeah, we won't go into the details. But yeah, this is just adjacency list representation. And in case of adjacency matrix, if there is an edge between 1 and 2, then you in this matrix, so this is like number of nodes cross number of nodes matrix. And then if there is a node between any two edges, if there is an edge between any two nodes, then you will add 1 over there, else you'll add 0. If it is a directed, sorry, if it is a directed graph, you will add the age weight over here, like 1 to 2, what is the age and all. So here it is just 1, 1, 1, everything over here. It's a unweighted graph. Here 1 doesn't mean that it has age weight of 1. It just means that a connection is 1 there between these two. So we are not treating it as a weighted graph. But if it were weighted graph, this means that all the weights are equal. Like the distance between every nodes is equal. So this is adjacency list and adjacency matrix representation. So in this case, we are just trying to write this adjacency list representation of the graph G to this file using this write adj list function. And then if you want to read that again, like You can store it for later use. Like you are creating a huge graph, let's say some social media network of 1 lakh people. You can't afford to, write that code again and again and then generate that graph and then do certain operation. You can simply generate that graph, write to a file, and whenever you come again, you can just use that file data and read that graph again. So nx.read, so write adj list will write that graph to a file, and read adj list will read that graph from the file and then import it in a graph variable called whatever variable name you want to give. So here I have given imported graph. Okay. So yeah, this was all about, different kind of operations that you can perform on for graphs. There are n number of other operations that you can that can be performed. So yeah, I'll urge you all to look into the details of this network X library. This was just the basic that you need to know. Okay, so let me quickly run this. Sorry, there's some random graph that is generated by that algorithm. So yeah, these are some different kinds of graph that you can generate. So this is a complete graph of 5 nodes. So let me just run this, in which every node is connected to every other node using with an edge. And then you can create a star graph in which a node is like a connected to other nodes in, and not other nodes are connected to other nodes. And then there is this random graph that we have seen earlier as well. It is the same algorithm, Adams-Rene graph. And there is another algorithm, GNP random graph. So this is same as this Adams-Rene, just the names are different. So internally, the functionality is just the same. Uh, just the naming is different. Like these are alias actually. They do the same thing. They accept same parameters also, like number of nodes and the age probability. So with what probability you want to, have age between two nodes. And yeah, this is also doing the same task. GNP random graph. So if you come across this function like in your quiz or somewhere, so it is accepting the number of nodes and then the age probability. Like what is the probability of having an age between any two nodes? Okay. And then there is this grid 2D graph function, which will create a grid graph, grid kind of a graph. So this was all about, different things that you can do with the Network X library. So is it clear, everyone, so far, whatever we have discussed? Yeah, for complete graph, it will be adjacency matrix will be all one. Yeah, that is correct, Leela. So any queries so far in whatever concepts we have discussed? Okay, great. So let us go on to discussing strings in Python. We have already discussed it, but you know, we're just discussing some revising certain things, and then also want to discuss some operations that you can perform on strings. So, in one of the sessions, like in the previous session, we saw that uh, tuples in Python are immutable data types. Like you cannot mutate any content of the tuple. Similarly, strings in Python are also immutable. You cannot change the um, any particular value or character in a string. For example, let me comment this out. Oh, before going into that, I forgot to discuss one particular concept that was unpacking of tuple. Yeah, there was an example over here. Okay, let me just copy this and show it somewhere. Yeah, let me just discuss this before we dive into. So this is the tuple, and then this star 1, 2 will, unpack this tuple and then give you 1 and 2 over here, like the way you do here. Sorry. You can either unpack tuple this way, 1, 2. So 1 will be assigned to A and 2 will be assigned to B. Yeah, while printing, if you want to unpack, so if you just print this, it will print a tuple directly. If you want to unpack it. So it will, uh, unpack it in unpack it and print it over here. So what is the use of this? Like if there is a function called, let's say, like sum, you are defining a function sum of two numbers, and then you're passing these two numbers and returning a plus b. So I can call this function as, sum of two numbers. Let us not confuse. So these are local, these variables are local to this. So let me just write this as CD just to avoid any confusion, but they don't have anything to do with this A and B. So this A and B and this A and B are different. So, sorry. So I can call this function as sum of two numbers C and D, and it will return me the sum. However, I can also call it like this. So this is also going to do the same thing. So once you unpack this tuple, one will be getting assigned to A and two will be getting assigned to B, and then this is going to, uh, uh, do certain operations later. So this was just like unpacking of tuple that is happening over here. So yeah, just wanted to discuss this extra thing which might not have been discussed in the course. So yeah, this was just for your information. And there is something called as double star as well. Like in the case of dictionary, if you want to, so uh, you can have dictionaries like let's say L, and then you have A is one, or let's say C is one, and let's say four, and D is five. I don't remember exactly, but yeah, it can be used this way. Oops. Yeah, I'll have to look into this. I'm not sure exactly, but yeah, in that case, what happens is like uh you assign this A equal to, let me just try it, A and B. I'm not sure though if it will work. Yeah, so I'll have to look into this, but there is something this double star as well in case of Python. So you can do unpacking of dictionaries as well, and yeah, that can be treated as like passing on this arguments to from the list to any function. So I'll get back to you on this. Okay. So yeah, till this point, I just is it clear? Just want to confirm. Okay, great. Yeah. So going into the list, sorry, strings. So yeah, if you try to access any element, so s of 0 will give you s. Sorry, s is a string over here. S of 1 will give you a, and s and so on. Okay. So if you want to, if you try doing this, like s of 2, I want to replace it with capital I, and if I run this, you will get this error. Sorry, uh, sorry, yeah. String object does not support item assignment. So if you try to replace anything in the string with another character, it is not allowed. You cannot change the original string. But what you can do is you can assign this like to another variable. Let's say A or S2. This is S1, and I'm doing S1 dot replace capital S with A, and let me print S1 and S2. So you can see that S1 remains as it is. S1 dot replace will just create another copy in which S is replaced with A, and it is assigning it to S2. But however, S1 is as it is. You are not changing S1. But if you want to change S1, you can just simply assign this back to S1. Okay. So you can just let me print S1 now. So you can see that S1 is replaced. So you cannot directly mutate something, but you can replace, create a copy, and then assign it back to S1. So that is possible. So is it clear, everyone? What is happening over here? Strings in Python are immutable. You cannot mute it. What if the variables are less than the number of elements in the tuple? So in that case, like if you don't have the default parameter, then in that case, yeah, you will get an error that you have not passed on. Uh, there are more elements in tuple. Then in that case, I think it will be like more number of parameters you are passing. So that will also lead to an error. So it will throw an error that you are passing more number of parameters than the expected number of parameters in function. The other way around. So if there are like less number of parameter items in tuple and there are more number of expected parameters in function, and you have not defined like, so for example, like if the function doesn't contain default parameters, like let's say c equal to 1. So if you pass this, this will work fine. However, like if this is not the case, if the function is accepting C and you are passing only 1 and 2, in that case also there will be an error that it was expecting one more input argument. So that was all about it. I hope it is clear. Okay, great. So for list, original list is changed when we do any changes, though we assign in separate way. Yeah, so here, like if it were list, for example, so let's say I have a list L1, 1, 2, 3, 4, 5, and L1 of sorry, L1 of 1 is 2. But I can do this. L1 of 1, I can just replace it with 6, and then let me just print L1. So I can mutate L1 elements. However, it was not possible in, you can do it in place over here. That's what I'm trying to say. However, you cannot do it in case of string. You will have to, transfer it to some temporary variable, or this will create a temporary variable internally and then put it back into S1. So that is possible, but you cannot directly change S1 here.
Sir, no, sir. The list, if we are changing anything, can we store that in a separate variable?
Uh, yeah, you can do that. Actually, you can do like this. So you can do L1 dot copy as we discussed in the previous session, and then mutate this L2, like L2 of let's say 1 equal to 6. So if you print L1 and L2, now L1 has the original list and L2 has a copy of L1 and then mutate L1. However, if you don't copy this, then it will be reflected in L1 as well. So you'll have to
Yes, sir.
take it.
But for string, there is a copy already. But
Uh-huh.
for list, we have to do a copy.
Yeah, yeah. So in string,
Uh,
you by default copy it, but yeah, in list, you'll have
oh,
to explicitly mention that.
oh, okay.
Oops, sorry. Yeah, it should be copied. Yeah. So this was about mutability of string. So strings in Python are immutable. Okay, so you can create a string. This is a simple way of just we'll go over all the string operations that you can do. So you can create a string, then you can access an element in string, like my string of 0 will give you the first element, my string of -1 will give you the last element or last character in the string. If you you can do splicing in string like you do in list. So if you want to take characters from certain position to another position, certain another position, you can do that. So that will give you a substring of the string. Okay. So there are two concepts in computer science. Like so there is substring, which is a contiguous string within a string, and there is a subsequence, which need not be a continuous. So HEOR is HEORL is a subsequence, whereas LLOW is a subsequence as well as a substring. Okay, so when you call string, so substring, it should be always a contiguous, uh, set of characters and not some random. So HELD, it's a subsequence but not a substring. Okay, so you have to be very careful about that terminologies. So greetings. So yeah, we have string concatenation. So you have this string one, there's another string two. So you can concatenate them using this plus operation. Here you are just adding this commas in between and the exclamation over here. So it would be hello, comma, space, Alice, and exclamation mark. Then you can find the length of the string, which is nothing but the number of characters in the string. Then checking if a particular substring is in a string or not. You can use the in operator. So if world is in my string, it will return true. If universe is in my string, it will return true. Okay, counting occurrences of a substring. So let's say hello is a substring. So my string dot count hello will give you the occurrences of hello in this particular string. However, if it is not present, then the count would be zero. Finding the index of the substring, then myindex dot find world will give you the starting position of that particular world substring. Replacing substrings. So my string dot replace world with Python. Okay. So again, this is not going to replace things in the original substring. It is only going to create a copy of it internally and assign it to new string. Okay. So this you'll have to take care of. Then you can convert a string to upper and lower, and then you can strip the white spaces around string. So like there are this white spaces or blank spaces. These are called white spaces, by the way, for those of you who don't know. So you can remove this white spaces or strip them using this strip function. So white space string dot strip will remove all this trailing and the leading and the trailing white spaces. Then you can split a string on certain delimiter. For example, my string is hello, comma, Alice, exclamation mark, let or hello world. And then if you want to break this string into multiple string or list of substrings, so you can do it using this split operation over here and pass on the delimiter. Okay, we'll see this one by one. Then there is this join operation. Okay, let me first discuss this and then we'll just run this and then so this join operation basically sorry joins all the words in this particular list with certain delimiter. The split function splits all the means the string into a list of words based on a delimiter, and then this join function it joins the words in a given or substrings, let's say, in a given list of words uh, with a delimiter, and then puts it in another string. Then string formatting we saw in one of the previous sessions, so you can even use uh, that while printing you can either have f over here and pass on the variable names in this, or else you can have this empty braces and then use this dot format and then pass on this entries over here. So Alice will be assigned to this first empty brace and 30 will be assigned to this second empty brace. It's a lot of information. Please don't be overwhelmed with this. Not everything is going to be asked in your examination. This is just for your knowledge that all these things can be done in Python. So my string starts with so it this particular function checks that if a particular string starts with a given word or not, or a character or not. And similarly, this particular function ends with checks if a given string ends with a certain character or not. As we discuss in the stylometry analysis, is AL num or is alphanumeric? We'll see if a given string is alphanumeric in nature. That is, if it contains only alphabets and numbers, or alphabets or numbers. Okay, it can be anything. It can be simply alphabets or numbers or alphabet number combination. Then removing leading trailing space, we have already seen this. Uh, yeah, so Is alphanumeric will see alphabets as well as numbers. Each digit will give you true only if the string contains only digits. Okay. Repeat string, like if you want to repeat a particular string like hello, 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 or so on. So you can just multiply them with the number, and then this will create a repetition of the string like ABC, ABC, ABC. Okay. So this is going to this particular operator is going to act like a string repeater. And then there are certain encodings in which a particular string can be encoded. Okay. So uh, we won't go into the details, but there is this UTF-8 encoding that is available. So if you want to encode your string in that particular encoding format, so you can do that and so on. So this is just for your information. And if you want to escape certain character, so as we saw, slash n is a new line character. Uh, so this will add a new line to any string. Like if you print something, it will be adding a new line over there. Similarly, if you want to, escape certain character. So if it were only n, so this would have been treated as a character n. What I'm doing is we are adding over here like this backslash, which means you are escaping this character and treating it differently. Similarly, over here, if you were to remove this over here, so the string would have been considered only till this point. However, we want this quotes also to be in the string. Okay, so this is a quoted string. So this I want this quotes to be in the string. So for that, we are just doing this using this backslash to escape that. Okay, so these are treated as normal quotes, and these quotes over here and here are treated as the quotes, starting and the ending quotes of the string. Okay, so this was all about it. So you can see in this particular string, escaped string. So this is the quoted string. You can see the quotation marks are also appearing over here. However, if you don't do that, then this will create an issue. Like you can see that only this particular part is treated as and then there will be an error over here. Okay, so you'll have to take care of all these things. So yeah, you can play around with this notebook at your own convenience. And yeah, and this was the last topic I wanted to discuss. Like matplotlib, we have already discussed, I think, in one of the sessions, like some basics maybe. So just quickly go over it. So matplotlib is a library in Python that is used to, generate plots, different kinds of plots. There are other libraries like Seaborn and other libraries. So you can definitely explore them as well. Uh, but matplotlib is widely used. And then what we are doing is we are importing matplotlib.pyplot as PLT. PLT as an alias, and you are using this for doing a lot of things in matplotlib. For example, you're creating so this np.numpy.line space or lean space, it will create a given number of numbers in a given range. So starting and ending. So 0 to 10, I want to generate 100 numbers. Okay. So at equidistant. So let's say it will like 0, 0.1, 0.2, 0.3, and so on. Something like that. Okay. So generate 100 evenly spaced values from 0 to 10. And then I'm applying this np.sign. Sign is the trigonometric sign on this x. X is like nothing but a vector which is containing this 100 numbers between 0 to 10, evenly spaced numbers. And then you are applying this sign on this, and then we are trying to plot this. So let me just run this code. So what's happening over here? So 0 to 10, there are 100 numbers generated. And for each number, you are trying to plot the sinusoid of that. So sign is a function, np.sign. And then you're plotting x and y. So plt.figure, figure size you are generating over here. Plt.plot, plot x on the x-axis, y on the y-axis. Label is the sine curve. Color is blue. Line style is dash, and then line width is 2. Line width means the width of this particular line. Okay. So this was about generating a sinusoid. These are just some examples I wanted to discuss. You can also add the x-axis label, y-axis label using plt.x label, y label, and title and legend. Legend is nothing but this particular legend over here that you can see, sine curve. Okay. So you have added title, this is X label, this is Y label, and this is a legend over here. So you can even set the font size for this X label, Y label, title, legend, and so on. So you can explore this in detail later. And if you want to save a particular figure, so you can use this plt.save fig and then pass on the figure name with the extension. So it is generally stored in PNG format. And this plt.show is used to only display it over here, this particular sinusoid that we have plotted. Then in this case, you are creating a scatter plot. So np.random.sid. So this is just for the reproducibility, as we discussed in one of the previous sessions, that you can set a random sid, and then whenever you use the random number, it will generate the same kind of random numbers for a given random sid. Okay. This will ensure. So in most of the machine learning applications and all, you'll have to ensure this random number generation to be happening in a similar way every time you run that code, so that the results are reproducible. Okay, so uh, yeah, you'll have to take care of this if you are going to use that. And yeah, so what we are doing over here, so we are generating 100 random numbers, and then we are just trying to pass on these 100 numbers to some function over here. Okay, some linear function, and let us just try to plot this. So what's happening? So you generated some random numbers uh, over here, and then you passed it on to this function 2x plus np dot random. Uh, so y equal to 2x will give you this line. For example, let me share this. Y equal to 2x. Sorry. Yeah. So y equal to 2x is a line function. And what you are doing over here? So y equal to 2x plus some random number. Okay. So you're generating some random numbers on the x-axis, then taking 2x of it, and then you're just adding some random number to it over here. So that's why in this particular plot over here is not a single line. So it is around this line with some random noise added to the points. Okay. And then you can have a bar chart, pie plot, whatever you want to have. So there are these categories, A, B, C, D, and then there are some values associated with it. So you're just plotting this plt.bar and categories and values and whatever color you want and so on. So yeah, you can explore details. These are just some examples of matplotlib library usage. So yeah, that was all about it. So let us quickly go on to the questions. So how can we identify which book is written by which author? And we'll end it shortly. Yeah, please quickly type in the answers in the chat. Okay, so I'll move on quickly by analyzing the word length distribution with previous books. Network access in Python is used for which of the following operation? Yeah, please try to answer quickly. Will Yeah. So many of you got it. Yeah. So visualizing social networks or analyzing social networks, generating social networks, and so on. So you can even have like, I discussed that you can find the shortest path between any two nodes. So any two nodes can be any two individuals as well. So you can be connected to some other person through some indirect connections. So there is this theory that on an average you can take seven or six hops between two people. So I might be knowing, the Prime Minister of India through some six people on an average. Okay, so I might know some other person A, and he may know B, and B may know C, and C may know the Prime Minister. So yeah, it might happen. So on an average, by analyzing some complex networks, people have found out that it is around six or seven. It may be fractional as well, so that doesn't make sense. But yeah, it is the case. So that was all observed from the data. So which of the following will generate a complete graph in Python using the NetworkX package? Yeah, please think over it and answer. So what we saw in GNP random graph function, the first one is the number of nodes, and the second is the age probability. And what is the complete graph? That every node is connected to every other node. So yes, somebody got it. So the correct answer is B, because you want to ensure that with probability one, you want to have age between every single node pair. Which of the following is true about 6 degrees of separation? That this is what something I was discussing just now. Yeah. So the average degree of separation of the nodes in the network is 6. The nodes over here is like the people. And also there is something I missed to discuss. So there is the concept of in degree and out degree of node. So let's say in degree and out degree of a graph. So in degree of a graph is nothing but like the number of edges that are coming to the graph. It can be in the case of directed graph, it can be, in this case, once in degree is 2 and its out degree is 0. Okay. And it could have been a undirected graph as well. This is directed graph. So in that case, in degrees and out degrees will be same. However, in case of directed graph, it will be, you know, uh, one has two in degrees but zero out degrees. So the node which has uh, all the out degrees but zero in degree is called as source node sometimes, and the node which has only in degrees and no out degrees is called a sink node. So it's like a source node and a sink node. So yeah, these are some terminologies in graph theory that you might come across. So that was just for your information. So is it guaranteed that the following code snippet will consistently yield a true result? G equal to nx dot gnp random graph 10 and zero point 0.5. Nx is connected G. Okay, what about others? I hope everybody is getting it. So this is relating to the previous question. So Nx the GNP random graph will create 10 nodes and the age probability is zero point 0.5. So this may or may not create a connected graph. So there is a probability of zero point 0.5 that there will be an edge between two nodes. However, it may be possible that a given node is isolated and it may not be connected. So the answer is false. So it won't be consistent. it won't give true always. However, if it were 1 over here, so this would have definitely returned a complete graph, which means that every node is connected to every other node with a with each probability of 1, and then is connected will definitely be true in that case. But in this case, it's zero point 0.5, so the probability of having an edge between two nodes in the graph is not 1, and then hence it need not be a connected graph. How many neighbors does node 4 have? Okay, it's not so very visible. So this is 1, 2, and 3, and 4. Yeah. So this is also straightforward. So answer is true. For somebody mentioned 4, so it's not like the neighbors are nothing but the immediate neighbors. So if you're connected to 1 and 2, means the 4 is connected to 1 and 3 here. So these are the neighbors of 1 and 3 are the neighbors, but 2 is not a neighbor of 4 because there is no direct edge between 1 and 4, or 2 and 4, sorry. So I hope that is clear to everyone. Uh, Masan, is that clear? Okay, okay, great. Degree of separation is equivalent to. Okay, this is also straightforward. The average length of shortest path in a graph. So yeah, the degree of separation is said to be 6 in a social network graph. Assuming that the length and breadth remain same, constant, how can we enhance the precision of the calculated area of a state? Okay, so this is something that we did not discuss, but there was a concept of calculating area using some by putting dots on the globe. So that maybe you can look into it. So it is discussed in the very last uh, lecture of the Swayam in the Swayam course in this particular week, week 9. So what is happening over there? So you have like let's say area of like a map of India, and then you know the actual um, uh, area of India, and you want to find so there is map of Punjab or Gujarat or Maharashtra or any other state. And what you do is you don't know the exact area of that particular state, like what is the area spanned by that particular state. So what you do is you just randomly throw in points on the image, and you see the ratio of the number of points. So this is like there are multiple points that you are throwing on the map. So let me just area of, I'm not sure if we get it, but yeah, something like this. So yeah. So let's say this is a map, and then you want to find out the area of a particular region. So what you do is you just throw out points in this particular sorry. So this is the area of a map, and then there are sub-regions in this, and you want to find the area of a sub-region, like let's say that this particular region. So you randomly throw out points on this image, and this can be done programmatically. And then you find out the number of points in this region, and then the total number of points. Okay, that will be equal. That ratio will be equal to the ratio of the area of this particular region and upon the area of total. So it is almost equal to not exactly equal, but as you increase the number of points, you will get a better precision over there. So that is the basic way in which they were trying to estimate the area of a particular region. It's not calculating it, it's just estimating it. So that was all about it. So The correct answer over here is like by increasing the number of points, you can get a better estimate of or calculate the area with more precision. Okay, so this was all about it. So yeah, okay. So that was it. So thank you everyone for joining the session. I hope it was useful and you learned something from this. And if you have any queries, please feel free to ask in the next session, which will happen on next Friday. So yeah, thank you for joining. Thank you. Have a nice one. I'll end the call now.